We'll start the session then. Good morning, all. Today we'll just go through the module 3, the introduction of module 3. Okay, as we are combining both the section, so that is the reason why I have left module 2 in between. We'll start with module 3. So if you just go through the syllabus of module 3 over here, it deals with embedded system components. As I told you earlier, for module 3, module 4, as well as module 5, you're supposed to refer the textbook second, that is Shibu KV Introduction to Embedded System. So this textbook you're supposed to refer for 3 modules, that is module 3, module 4, and module 5. Okay, so basically in this module, in module 3 I'm speaking, embedded system components. If you have any problem, please let me know in between. Under this module, under module 3, basically we are dealing with embedded system versus general purpose computing system. What is embedded system? Why applications of embedded system? And different components available in the embedded system, like various sensors you are using, which are the different types of sensors or the actuators. So all those particular topics you will be studying in this particular module. Okay. So we'll go with the introduction, that is embedded system components. First of all, can anyone tell me what is embedded system? Anyone? You can type in the chat also, you can type, not a problem. Or you can share. Anyone? Can you tell me what is embedded system? Yes, Dilip. What is embedded system?
It is a part of the computer system.
It is a part of a computer system. It is a computer system, right? It cannot be a part of a computer system. But whenever I say embedded system, it is meant for a particular application. Is it correct? Embedded system is nothing but an electronic or electromechanical system which is designed to perform a specific function, and it is a combination of both hardware as well as the firmware, right? So you can observe the keywords here. It is an electronic or electromechanical. It can be an electronic system, or it can be an electromechanical system. Electromechanic in the sense, if you consider any example, any simple example you consider, say for example, automatic door opening system. Whenever a person comes near the door, it has to be sensed, right? Based on that sensing, automatically door has to open. Wait a second, I will mute. I request all the students to mute from your side. I hear a lot of disturbance in between. Can you mute from your side? All of you, please mute. When I ask you any questions, and at that time you can unmute. Okay. Basically, if I continue with the same example, like automatic door opening system, whenever a person comes near the door, it has to be sensed, right? Once sensing is done, an action to be taken. So in order to take an action, so either say a motor should be connected so that the door has to open. So we can consider total system as an electromechanical system, right? Which is designed for a specific function. It cannot be a general purpose. It has to be designed for a specific purpose, right? That is, say, door opening system. I can use it only for that particular application. It cannot be used for any other application. So simple examples are given like electronic toys, mobile handsets, washing machine, air condition, automatic control units, various things. Embedded system, this is one of the important feature, or we can say it as a characteristic. Embedded system, it is unique in character and behavior, as well as with specialized hardware as well as software. So before getting into what exactly the embedded system or the components of embedded system, you need to make sure the difference between a general purpose system as well as embedded system. I think you have already come across this, what is general purpose system and what is embedded system. If you consider your microprocessor, say 8086 microprocessor, what you have studied, we can we can tell it is nothing but a general purpose system. So basically it is a system which is a combination of generic hardware as well as general purpose operating system, right, for executing a variety of applications. Whereas embedded system, it is meant for a particular applications, right? In general purpose, you consider your desktop. You can use your desktop for various n number of applications. So here we'll be using general purpose operating systems like Windows, something like that. In this embedded system, we will have specific applications, sorry, specific operating system. We call it as a real-time operating system, and it is optional. Again, in embedded system you may have an operating system or you may not have an operating system. It totally depends on this type of application you're going to use. Okay, applications are alterable or programmable. It means that whatever applications you run, you can reprogram it and you can rerun it. It can be done a number of times. Whereas here in the case of embedded system, once it is programmed, once it is given to the market, again the user doesn't have a provision to reprogram it. It is fixed. So it has to be done during the design phase itself. Performance is the key deciding factor in case of general purpose system. Whereas here, there are a lot many factors. In case of embedded system, there are a lot many factors which we need to take care, like power constraints we need to take care. We need to take care of memory usage, because whenever I say embedded system, everything in the sense, the memory, the interfacing units, the hardware, everything is been clubbed together and it forms an embedded system. Whereas in case of general purpose system, it is totally a different thing. I have a provision. If just consider your desktop system, suppose say if you feel that your desktop system is not working according to our need, or it has slowed down, what we do usually do is we can have an extra RAM, or we can replace the RAM with high efficiency, something like that. But in case of embedded system, it is not possible, right? During the design phase itself, it has to be done. So after designing, say if you say that the memory is not sufficient, we need to update it. It is not possible. Either we need to redesign the entire system or we need to go with the other system. So we say it is firmware is pre-programmed and it is not alterable. And here the performance is the key deciding factor. Here there are various other factors. Less tailored in the sense, as I told you earlier, during initial stage of general purpose, we don't initially decide what should be the RAM memory, what should be the hard disk. It is basically based on like a trial and error technique, it will be decided. Whereas in embedded system, it has to be decided at the earlier stage itself. One should know exactly what should be the RAM, what should be the ROM size, how many input output devices should be there. All those should be decided earlier at the design phase, and then it will be given to the next process. So in between, it is, so we call it as a highly tailored, and the general purpose as less or not at all tailored. Okay, here the response requirements are not time critical in case of general purpose system, whereas in embedded system, the response, it is very time critical. Time critical in the sense, as already I have discussed with you, basically when I consider real-time systems, embedded system, basically it is a real-time system. Why we call it as a real-time system? Because it has to generate the output or whatever, the application has to be run within the time interval. Basically in real-time system, again there are two types of system, right? That is hard real-time system and the soft real-time system. Whenever I say hard real-time system, it means that it has to perform the application, or it has to execute the application within the time interval given, right? Within the time interval it has to execute and it has to produce the output. And whereas soft real time, occasional failure of the system is fine, it is acceptable. Continuous failure should not happen. Occasional failure, so for example, if I consider airbag system, it falls under a hard real-time system where the failure is not at all acceptable, right? Whereas if I consider an ATM machine, we can consider it as soft real-time system where the failure doesn't affect the environment. Occasional failure is fine. And it need not be deterministic in the execution behavior. Deterministic in the sense exactly this is the output has to be generated, or at this instant it has to be generated. It is fine. Whereas here execution behavior, it is deterministic for a certain type of application, especially for the hard real time. It has to be executed within the time interval given, or else there will be a lot of damage to the external environment. Coming to the history of the embedded system, uh, basically this embedded system is classified into in four categories. It is based on the generation it has been classified, it is based on the complexity and the performance requirement it is classified, and based on the deterministic behavior, and based on the triggering. Coming to the first one, based on generation as well as based on the complexity and performance, almost the explanation falls same. Can anyone tell me what is based on generation, how this embedded system is classified? Anyone? Based on the generation, how this embedded system is classified? You can type the message in the chat, in the group chat, you can text it. See, generation, it is classified as a first generation method, a first generation system, second generation system, third generation system, and the fourth generation. Right now, what we say, we can tell it we are in the fourth generation. So anyone on what is this generation, based on what this generation has been classified? I hope you have the PPT also with you. Right, so you can observe here the first generation, it is built around 8-bit microcontroller. Basically the size of the microcontroller will matter, right? We have seen 8051, if I consider it as an 8-bit microcontroller. We have 16-bit ARM controller, if you consider what we have studied in the last first two modules, right? It is 32-bit microcontroller, right? Also we have 64-bit controller. So based on the size of the controller, this classification was done, right? The first generation, say 8-bit controller, sorry, second generation built around 16-bit microprocessors or 8 or 16-bit controllers. Third generation built around high performance 16 or 32-bit microprocessor controller, and also application specific instructions set processors like DSPs and ASICs, that is application specific integrated circuits. Fourth generation was built around system on chip. System on chip in the sense, yeah, we have a microcontroller, the ARM controller, whatever we consider, whatever you have dealt with in the lab, it is nothing but SoC, system on chip, where we have an core controller. Along with that, various peripherals are there, all the interrupt, all the various other features like inbuilt DAC, inbuilt ADC, inbuilt PWM. So many features have been embedded together, and it forms an SoC. It is nothing but the fourth generation. We call it a system on chip, which has all the features which is required for the embedded system. Whereas in the previous versions, if we consider like first generations or the second generations or the third generations, if we consider, in this case, basically we don't have, say we have a controller, but if you require some input output peripherals, like you require a DAC or you require an ADC or you may require a PWM, it has to be interfaced externally, right, in the first two generations. Whereas here in the fourth generation, everything is inbuilt, it is within the chip. So that is based on the generation. Next one, it is based on the complexity and performance. Here we have small scale, medium scale, and large scale. Okay, so basically till now what we have done is we have studied this embedded system. Right now you know what embedded system is. Embedded system is nothing but electromechanical, electric or electromechanical system which performs a particular action. And also we have seen different applications of embedded system. Okay, and classifications of embedded system based on the generation we have classified. Now we are dealing with the complexity. Okay, small scale, medium scale, and large scale. Here also you can observe basically this classification is done based on the size of the controllers, say 8-bit microprocessors or the 4-bit microcontroller, which fall under small scale. It basically depends on the application. It may also depend on the application. Like if I consider a small toy, where you want to move a toy in forward direction, backward direction, right, left, that's all. In that case, sorry, in that case, I think small scale is sufficient. An 8-bit microcontroller or the 4-bit microcontroller is sufficient for us, right? Design, using an ARM controller or 32-bit microcontroller or 64-bit microcontroller for such a small application is not at all acceptable. Based on the application also, we can classify this very small scale as well as some medium scale. That is the embedded system, the application which is built around 16-bit microprocessors and an 16-bit microcontroller, right? And the large scale, ultimately, it is nothing but where you require a lot of what say computations, like you may require DSP, digital signal processors, or application specific. You may need to process the signal sometimes, and then you may need to monitor something. In that case, basically we go for large scale design or large scale embedded systems. So you can call it as, based on the applications, we are going to classify the small scale, medium scale, as well as large scale. So that was the classifications based on generation and based on the complexity. And the next comes based on deterministic behavior. Already I have explained you, based on deterministic behavior, in the sense it depends on the system which you are going to use. Basically two category. There is hard real-time system as well as the soft real-time system. I request all the students to mute from your side. uh, Based on the deterministic behavior, hard real-time system as well as soft real-time system. When I say hard real-time system, as you know, behavior, it has to be executed within the time interval. We are going to set up a time, say for example, airbag system. As you know, the function of airbag system, whenever the car collides, at that instant, immediately the airbag should open. So the response time of that particular device, say within 2 seconds, it has to execute and airbags should open. So we call that 2 seconds as nothing but a deadline. So within the deadline, it has to be serviced. So that is deterministic behavior. It has to be executed within. Soft real time is nothing but occasional failure is fine, but every now and then failure, it means that failure in the system. So occasional failure is acceptable. So we call it as a soft real time system. So these are the two classifications basically based on the deterministic. The fourth one is based on triggering. Okay, based on triggering in the sense how we are going to enable the system or enable the embedded system. So enabling can be done by various techniques. It may be based on some event. If that event occurs, you have to enable it. Say airbag system, collision is nothing but an event. It has to, that is nothing but it is trigger the event. Or you consider a chemical reaction. Chemical reaction, say for example, I have one chemical, a reactor, or it has to be turned on, or it has to be like, it has to be processed, say for time interval, say 10 seconds. In the sense 10 second is nothing but my interval. That is like a periodic one. Okay, here basically we have two types, periodic and non-periodic. Periodic in the sense we know exactly at what time interval it has to start, it has to execute, and it has to stop. That is nothing but periodic. Chemical reactions, everything, if we consider it as a periodic system. Whereas non-periodic in the sense I don't have any information at any instant of time, an event may occur, right? So such type of system, we call it as non-periodic. So based on triggering, it falls under triggering, based on triggering, periodic event as well as non-periodic event. So these are nothing but the classification of embedded system. Okay. Coming to the application area, a lot of applications you can find in your day-to-day life. You can just go through it, like consumer electronics, camcorders, cameras, household appliances like televisions, washing machine, DVD players, fridge, microwave, and so on. Home automations, in home automation as well as security systems. So many applications you're going to use. Telecom systems, as well as computer peripherals, computer networking system, healthcare systems, measurement and instrumentation, banking, card reader. There are a lot many applications in case of embedded system. So these are the various applications. Coming to the last content for today, that is nothing but purpose, the need of embedded system. So basically, these are the various needs. Each embedded system is designed to serve the purpose of one or more combination of the following task. Okay, embedded system may have a particular combination, or it can have two or three, more than two combinations. Say, basically, embedded systems are used for data collection. You need to imagine the things right now. It can be used for data collection, data storage, data representation, right? Simple example is nothing but the camera, right? So you can observe here, first step, first one, data collection, purpose of an embedded system, data collection, data storage, and data representation. Like first you need to acquire the image. Once an image is acquired, it has to be stored in a particular format or a pattern, how it has to be stored, where it has to be stored, in which location it has to be stored, and it has to be represented in a particular section. So that is first purpose of an embedded system, that is data collection. It need not be only a camera. Data collection need not be only a camera, it can be any other things, right? Say suppose you want to read some signals from the external environment, it is also data acquisition. So you need to read the temperature. So how we are going to read the temperature? How we are going to read a temperature? It is also a data collection, right? Once the temperature is read, how you are going to store it, where you are going to store it, and how we are going to represent it. All those are nothing but a data collection, storage, and representation. That is the first purpose. Second purpose, say data communication. Now you have a data, right? It has to be communicated somewhere. It has to be sent somewhere. So how that can be done? How you can communicated. So that also that is also a part of embedded system, data communication. So there are various applications. You're going to study this in the coming modules of all these particular techniques. So you can observe systems are deployed in the applications ranging from complex satellite communication to simple home networking systems, like Ethernet, RS-232, USB, IEEE 1394, wireless interfaces like Wi-Fi, GSM, Bluetooth, Zigbee, etc. So some of the components you're going to study, some protocols you're going to study under this particular module. And as well as in CCN, you might have studied about network hubs, routers, switches, modem, etc. All those are nothing but a part of an embedded system. When I say router, it is also, it has to receive a particular message, it has to receive a particular packet, deframe it, and then transfer it, right? You can relate this particular section to your CCN concept. So it has to be done. So some processing unit should be there. So that is nothing but an embedded system. So the first purpose was like acquiring the data, getting the data, storing it, and representing it. And also next function is like data communication. It is used for data communication. Third one, very important thing, is signal processing. Okay, but it's not only embedded system is not nothing but is not only used for like data collecting and then storing it or sending it somewhere. It has to be the signal, whatever we are going to receive, it has to be processed, right? So how we are going to process based on the application, either you can use DSPs or the ARM controllers are sufficient sometimes, or any other ASICs, application specific integrated circuits you can use, right? So basically you require some processing unit in order to process the signal. Computational intensive systems. This is say one digital hearing aid figure is shown. As you know that whatever signals or whatever you're going to hear, the analog signal will be received and it has to be converted, right? It has to be converted and that signal should be transferred. It has to amplify and then transferred. So basically it has to be converted to digital signal and then amplification should take place. So all that will be done using digital signal processing unit. Next, a function. So three functions we have seen, starting from data acquisition, storage, representation. The previous one, uh, data communications, data signal processing, and next one is monitoring. Embedded system also plays a very important role in monitoring or anything, any systems, or the condition of any system, or the condition of health condition of human beings, the environment condition. So many cases this embedded systems are used. Simple example, a patient monitoring system device in hospitals, you might have checked this, where you're going to monitor ECG signals, EEG signals, where the temperatures will be displayed, the heart